Welcome to the video on stack organization in microprocessor. Myself, Jinesh Julia, and my ID number is 21DC020. In this video, we will discuss what a stack is, how it works, and how it is used in microprocessor. So moving on, what is stack? A stack is a region of memory that is used to store data temporarily. It is a last in, first out, which is also known as LIFO data structure, which means that last item to be added to the stack is the first item to be removed. A stack is typically used to store return addresses, function parameters, and local variables. And before that, we will understand about a subroutine. In a microprocessor, a subroutine is a sequence of instruction that performs a specific task or function within a program. In microprocessor, the stack is used to store the return addresses of subroutines. When a subroutine is called, the microprocessor saves the current addresses of the instruction pointer onto the stack. This allows the microprocessor to return the correct location in the program after the subroutine has finished executing. Uh, on to the overflow. When stack overflows, the excess data can overwrite other data on the stack or even overwrite critical memory location outside the stack, which can cause program to crash or other unexpected behavior. To prevent stack overflow, it is important to carefully manage the stack pointer and ensure that the stack has enough space to hold all of the data that is being pushed onto it. So we will now look into an example. For example, we have an stack of elements 5. So we are pushing 1, 2, 3, 4, 5. And if we want to push 6, then it occurs an overflow condition. So we need to be careful about the stack overflow condition. And similarly, there is an condition. It is important to note that stack has a limited amount of space, and if too many items are added to stack, it can overflow. This can cause the microprocessor to crash or behave unpredictably. Similarly, if too many items are removed from the stack, it can overflow. This can cause the microprocessor to crash or behave unexpectedly. Similarly, if too many items are removed, it can cause underflow. So here we have an element of 4, say, and we are removing all the elements, and we are at the last we have 10 on the bottom of the stack. And if we want to remove 10, we will be having an empty stack. So if we are having an empty stack, there is no element in the stack. So if we try to pop out the uh, from the stack, so we will face an error. So moving to stack organization in microprocessor. So in microprocessor, stack is of a user 64 bits. So uh, and in first we have a stack pointer contains 6 bit because there is 64 words of bit address. When there is a 63 incremented by 1, the result is 0. So it is kind of a circular queue, and there is a two flags. So for example, full is equal to 1 when stack is full, and empty is equal to 1 when stack is empty. DR is data register that holds the binary data to be written into or read out. Initially, stack pointer is 0, empty is 1, and full is 0. So we will be seeing this stack organization in implementation in memory stack. So here you can see that memory stack. So here we are having a three from 3000 to 4001. We are having a stack or organization. So computer memory partition into three segments: program, data, and stack. What do you mean by program counter? Program counter points at the address of the next instruction in program, and it is used during the fetch phase to read an instruction. Second is address register, which points to an array of data used during the execution phase to read an operand. And stack pointer points at the top of the stack, used to push or pop items into or out from the stack. So, in memory stack, we are actually trying to store all the data regarding the microprocessor or of instruction. So first we will be looking at the program counter, which actually stores the instruction what is needed to be executed on the function or anything like that. And a second is address register. So it stores the address of all the variables, all the operands. So it is convenient for us to point to that. And stack pointer points to the values which is used to insert into stack or like that. Uh, and I guess it's goodbye for now. Thank you.